So first of all, I know you've been sitting for a while, and from what I could tell, most of you have been sitting very patiently and mostly awake. But I'd like to ask you at this point to all stand up and turn to your left and turn to the right, just to move around so I have a better chance. Stand up, come on. I want to keep most of you awake till the end, and this increases my odds. Okay, sit down. Good, move around. All right, we're ready to go. This should be, for some of you who know benchmarking, you may be here to learn inside tips. For some of you who don't know benchmarking, you may be very interested in finding out about what it is. What I can promise you is by the end of my talk, I will teach you the secret keywords to make you sound and act just like a benchmarking guru. And I will bless you at the end so you'll all be benchmarking gurus. Benchmarking. To talk about benchmarking, the first thing we have to talk about, let me get my, there we go, that's me. So if we're going to talk about benchmarking, the first thing we need to talk about is what is benchmarking, the definition. I will give you 3 definitions from historical references that will be a start, and by the end, hopefully, you'll see examples that will help you understand what I mean. The first example is my favorite just because it makes for a great picture. In the old days of people making shoes carefully by hand, cobblers, the shoemakers, would have a bench they sat on. A person would put their foot up on the bench, and the cobbler would trace a pattern around their foot that would become the benchmark for that person's foot. They could then make additional shoes very efficiently and quickly, theoretically all fitting really well because they took a benchmark. The second historical reference, if you look up the term, is actually to surveying. When people would go out and measure objects in nature, or they would be surveying to build buildings or find property or country lines, surveyors would put marks in the ground to both mark where they took measurements and mark specific geographic positions so that people could refer to those marks when they looked at maps and so on. The third definition that I'll use is one that started in the 80s. Xerox Corporation was trying to understand why they were having problems competing, why their competitors were regularly beating them in the market. So what they did was they went around and they studied their competitors' products, they studied their competitors' manufacturing processes, their sales approach, their support, and they called that benchmarking. So you'll hear the term, there's at least 3 definitions. But I'm sure you've all actually had real practical examples of benchmarking. In the United States, anytime you buy a new car, it's required by law that it have a sticker on it that tells you what the fuel efficiency is. This sounds very simple. Actually, in 2007, one of the problems customers were having is that they rarely were able to achieve the gas mileage that manufacturers claimed on their cars. So the United States government, being as helpful as always, decided they would improve the standard to make the measurements more realistic. What they did was they modified the specification which governed the required reporting. The update for the specification in how they changed rules was 19 pages long. Wait a minute. The actual specification for how to measure and report fuel mileage, 179 pages. Now, you might say, wow, that's a lot of pages. But if you think about it, they're trying to do a very specific measurement so that it was repeatable, and so that it was likely that people would experience it, and so that the people reporting it wouldn't cheat. Okay? Or, sorry, they wouldn't exaggerate. So why would you benchmark? First of all, how many people in this room would consider themselves benchmarking practitioners? Just show of hands. Okay, I see a few of them. I'm going to guess that it's very rare that you do it for fun. Like okay, I admit, I'm weird. I actually enjoy it. I've been doing it for 30 years, and I'm still doing it, and I like it. But I'm weird. Most people are doing it to answer a question, to solve a problem, to prove that a system is worthy. It's very important if you're going to go to the trouble of doing benchmarking that you have very good questions in order to benchmark. Otherwise, it becomes entertainment. And unless your employer is interested in supporting your hobbies, you have to have very detailed questions. Here's some examples of questions that are not detailed enough to benchmark. And I know if anyone wants to shout out what's wrong with these questions, maybe you can't even read them. I'll just give a few seconds for someone, if they can see what's wrong here, to shout out what's wrong. 1, 2, 3, no. Someone said something? What? No. Shy, again. They're not specific enough. Let me take the last question. The last question says, what instance type will it take to support 1,000 unique users on AWS running Drupal? That sounds very specific. The problem is, if you were asked to go and measure this, you have to actually say, what is a user? What is a user doing? What version of Drupal are you talking about, right? What features of Drupal are you using? You can't benchmark something that's not specific enough. Another example, for those of you that have ever had courses in programming, one of the first courses any good professor will do, the first assignments, is write a simple algorithm for how to do a household chore. For me, in my first programming class, and I'll just say it was in the 70s, so let's leave it at that, was how to cook an egg. How to cook an egg sounds very simple, except when you get to the level of detail to make sure someone can do it right and do it repeatedly, it gets really tough. Benchmarking on premises is actually really tough for a few other reasons. The first thing is, in order to do a benchmark, if you're doing performance or stress testing, you need to have a system to run it on. Usually the best systems are in production, and so you're asking for extra systems to go out and run. If you can get them, it sometimes takes a while. The other problem is sometimes when you get them, the reason you got them is it's the old and antiquated equipment because nobody found it useful. And when you try to benchmark on the old and antiquated equipment, you get answers, but it's like asking, what's the latest technology for... If you look at the sports Olympics, if you look at the speeds that runners run at now versus what they ran 30 years ago, the benchmark has changed for whatever reason. So you need relevant equipment to do tests. The other real problem with generating load in benchmarking is it requires a lot of extra capacity. If you're going to stress test its system to its limit, then you typically need more capacity than you normally would use. Sometimes you need as much capacity to drive load as you do to handle it. And that requires, if you go out and get capacity, that when you're not testing, you've got all this spare capacity sitting around. Finally, whenever we run tests, whenever we do benchmarks, we never run a single test. Why do you never run a single test? If I run one test and I get an answer of 5, and then I run another test and I get an answer of 3, who can tell me which is better, 5 or 3? Nobody can tell me, because until you know the context, is higher better, is lower better, are the units the same, you can't answer that question. If you have 2 results and they're very different, which one is right? You don't know. You run multiple tests. You do deep analysis to make sure you can trust what's going on. So now, be prepared. Get ready to take notes. I'm going to teach you the 2 magic words that will make you sound and appear like a benchmarking guru. Are you ready? Everyone's ready? Okay. It depends. Okay? You've all got that, right? Okay. So, how do you use it depends? Someone says, why, Robert, how many users can I run on my instance of Drupal? And I would say, it depends. And then they would say, what do you mean it depends? And I would say, well, it depends on what version, blah, 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 blah. If you're really good at this, you can keep asking so many questions that their eyes glaze over, and they forget that you're there, and they walk off and they walk into the walls and say, wow, I talked to Robert and I can't remember my name. I don't know what happened. Okay, so in contrast to benchmark, as someone who has been doing benchmarking a while, I have to tell you, using AWS, using the cloud for benchmarking is really great. One of the issues is you can get answers very quickly. If you're doing a long-running systems test, let's say it takes 3 full days to run your test. And remember, we never run it once. So you're going to run it 3 times. You won't run it twice because 2 is an even number, and if they're both the same, what do you know? So you need an odd number. So you're going to run it 3 times. 3 times 3. That's 9 days from the time you start your test to when you'll have an answer. With the cloud, you can start up 3 instances and 3 sets of tests, run them all in parallel, and in 3 days have an answer. And essentially, it'll cost you the same. You're running 9 days worth or 9 days worth just in 3 calendar days. That's a good thing. The other really great thing is you pay for what you use. A lot of times people ask questions. They say, what's the capacity of this instance type versus that? How does it compare? What we really like to tell customers to do is test it. Now, I'm going to spend the rest of my talk talking about what exactly that means and how to go about benchmarking in some specific examples. But The nice thing is you can take our largest instance size, a massive CC2 8XL, and you can use it for 2 hours and get results if that's all it takes, and that's great. Elasticity is a really important part of AWS. You have both horizontal and vertical scale. You can create an image with your tests on it. You can run it on a very small instance. You can take that same image and run it on larger and larger instances. You can do them all in parallel, and you can say, what do I get when I run on these? You can also build very large, complex systems using some of the tools we have like Beanstalk, and build whole systems, and again, you can test them in parallel. So that elasticity is really important. So automation is really important. If you're going to run these tests over and over and over again, I don't know how many of you have ever had this experience, but from my experience, humans are really bad at doing things repeatably and predictably. They make lousy test load generators. They make great end-user functional tests, but you cannot get them to do the same thing very accurately over and over again. All of our APIs are programmable, so things from deployment all the way to analysis you can do really easily. I guess I would summarize it by saying AWS is a great place to do benchmarking. To talk about benchmarking, though I've been using that term, let me go into more detail about what I mean. There's a few key things you need to look at anytime you're trying to think about doing a benchmark. There are the 4 elements in my picture here that are all blue. Are the ones that every benchmark has to have. First, you have to have workloads. That's a description of what work is being done, what kinds of users you have, and in what combination they're doing work. The second one is load. If you're going to do tests, as fascinating as it might be to run a single user system, I don't know many people that go to the trouble of building a complex system and having a single user. You need multiple users. You need to be able to generate realistic load. Third, you need metrics. You're usually going to want to turn data into information. In order to do that, you need the data. You need measurements. So you need to think about where those measurements are coming from. Last, you need to have the report. In fact, whenever I go about benchmarking something, the first thing I do is say, what's the report going to look like? That tells me if I've defined the key elements. That tells me if I've thought about what data I'm going to need in order to generate the report, what load I'm going to need, how I'm going to generate that load, and finally, it tells me what are the workloads and how are they going to be combined. Like any software project, there are really well-defined stages of a benchmark, from the design of the test all the way through the configuration, execution, and the analysis. What's really important is you apply a very disciplined and scientific approach to doing your experiments. There's a few key things to think about. First, remember the word adequate. This is another guru word, so remember, pay attention, adequate. Adequate, for most people, sounds like a bad word. If your son or daughter comes to you and says, look, I got an adequate grade at school, you would say, oh, sorry. But when you're doing performance measurement or benchmarking, the first thing you have to define is, when am I done? What I've seen many times with junior benchmarkers is you tell them to make something fast, and you need to go and make sure that they're actually eating food and sleeping regularly, because you can always make it faster. You need to start by saying, when am I done? And having a very disciplined approach, changing as few things as possible, tells you that the things you're measuring are actually somewhat close to what you're trying to observe. Last point on generalities here. There's something called the Heisenberg principle, which says the act of measuring something changes it. So you need to be very careful that you're actually measuring what you think you are, rather than measuring the way you're measuring. That sounds complicated, but I'll give some examples. So now you're all entirely motivated and mostly still awake, and you now say, Robert, benchmarking, how do I do it? There are 3 choices. The best choice is where you take your application and you benchmark it. That sounds simple, but it actually is a good deal of work, and I'll talk about that. The second choice is for sometimes you don't have time, and you want to go out and use a benchmark that someone else has created. I usually refer to these as standard benchmarks. Sometimes there are other things that I'll call more benchmarking, but there are lots of tests that are well-defined and well-built and can give you meaningful results, but there's some work in terms of doing that. The third and least desirable choice is when you go out and just read a report that someone else has done. There's a lot of issues with doing that, and I'll talk about those. In the remaining slides, it's really going to be how you go about doing these things and examples of each. So the first, it sounds really simple. Oh, just go benchmark your application. Remember those 4 elements? You need to figure out for your application what subset of your application you're going to test. You can have many, many, many features, but you probably aren't going to want to test every single one. That's more of a functional test. If you're trying to mimic what your system's going to look like, you're going to pick which features, what kinds of users, in what combination, what kind of load. Next, you're going to have to figure out how you're going to measure it. Do I have the metrics I need? Are they available in the platform? Are they built into my application? Believe it or not, sorry, I skipped load generation. Load generation is really important. As I mentioned, humans are a really bad choice. They're just not reliable enough. So you can use programs that you write yourself to synthetically generate load. There are partners out there that you can find on the AWS website that make it a business to generate load at huge internet scale. You could enlist humans. In fact, you could use a service like Mechanical Turk, write scripts and pay people essentially to go run your scripts. I think getting food and drinks is a better bribe because you get people more motivated to do it when you want. They don't do it on time. They don't get their food, blah, blah. So anyway, we've got load. We've got workloads. We've got load. Metrics, it's very important that if you need detailed metrics in the application, sometimes you have to add them to the application. Just be careful. Sometimes, remember the Heisenberg principle, if you turn on detailed logging, it's actually going to change the behavior of the app. Sometimes you can cause bottlenecks by turning on too high a level of logging. And finally, the report is really the key. Does it give you the information you need to answer those questions that you were trying to answer? So let me give you a graphic example from my own experience. I had taken over as general manager of an engineering organization that was worldwide. We ran one of the world's largest enterprise portals, along with some other commerce-type websites. We're talking huge numbers of clients coming. Every year there was an annual renewal. I took over this organization in November, and my first meeting was what we called a go-no-go meeting, which is where the engineering team, the business, the operations team, and support all got together and said, we're about to release something. Do we think we'll keep our jobs after we release it? Have we done a good job? Are we ready? Do we really have a good story? Since I was the new guy, I really didn't have any authority. So I was just there as an observer. I asked 2 questions. I said, the first question, what were your performance goals? The second question, how did you measure them? Their answer disturbed me a little bit. The answer was, oh, we tested it 2 releases ago. It was great. We haven't really changed much since then, so we're good. I paused. I was very polite. And I said, okay, so what is your rollback strategy if this doesn't work right? And they said, oh, we've got detailed plans. It's all detailed in a spec that everyone knows. I said, fine. January of that year, so just a couple months later, my first visit to India, I was visiting part of my engineering team that was in India, I get a call at 2:30 in the morning. I get a call from my manager, who's gotten a call from his manager, who's gotten a call from the president of the company. This is a very large company, so that's a big deal. It was not a friendly call. The website was not performing. Someone had blogged about how it wasn't performing and made disparaging remarks about the president of the company, saying they weren't being very nice. I'm paraphrasing here. Needless to say, it was a crisis. So I asked the engineering team there, so what workloads have you defined? Where's your load generation? What can we measure? And I got blank stares back, which really concerned me. It turns out they didn't have any of this. The real problem was the only way we could fix this problem was make real-time changes to the production system. So we would literally go in, make some changes. We had no way of testing them on the side whether they worked. If they weren't working, we would roll them back, and we'd try again, impacting customers. Bad story. It actually took 6 months after the emergency was over, with the highest priority, for the IT organization, to order the equipment, get it provisioned in the data center, get it cabled up, get the tests written, get workloads, and to make that kind of testing something that they would do before they released again. Now, the flip side to that is what I would do today is, even if I didn't have the workloads defined, I would have instantly spun up extra systems, restored production copies of the database, and tried to reproduce the problems by playing back logs or something else. Very different scenario. But you can see, even if you've got a running application, it takes some amount of work to test your own app. Most importantly, like any software, the bugs you find later on in life are the most expensive to fix. To me, performance is not a feature. It's not something you can cut. Oh, we don't have time for performance. It's an attribute that must be there. You got to build it in, or it's expensive to fix. Okay, off the soapbox. The second of my three choices from doing your own workload was to use a standard benchmark. The good news about using a standard benchmark, the workloads are defined, right? The load generation usually built in. They give you a tool. The metrics are built in. The reports are all done. Sounds great. The real problem is, well, besides, you've got to do some amount of tuning, and sometimes that amount of tuning can be extensive before you know whether you've really got a good result. How do you know it's good? It feels like it is? No, you have to do some amount of work. The real challenge, though, is this benchmark relevant? I had some questions I was trying to answer. Let's take an example from the database world, TPCC. If you've ever looked into detail at TPCC, it has extravagant storage requirements in terms of the number of disks and how you have to scale it. Very unlike what most customers would need even today in the internet scale. And if you have TPCC results, the real question you have to ask is, what does that mean for me? How do I extrapolate from that? And you have to say, how is this test written, and how does that map to how my app actually works? Now, another example. So I was asked, Sundar talked about DynamoDB. I was asked to verify our claim. If he said single-digit latency, being a benchmarking person, I'll have to pick on that a little bit. What we say is that DynamoDB provides single-digit millisecond server-side latency. Slightly different, again, picky, but that's my nature. But I was asked to verify that because the engineering team had done a lot of work, and they wanted someone who wasn't part of that effort to say, is it true? I had 2 weeks from when they asked me to do this till they planned on releasing, so I didn't have a lot of time. What I did was I went out and found something called the YCSB Yahoo Cloud Serving Benchmark, which is a really extensible framework specifically designed for comparing NoSQL type databases, but it can actually be used for lots of things. So what I did was I used that, but I even used the parallel aspects of AWS to tune the clients. Remember, I'm testing servers. I'm not trying to test clients, but in order to generate load, you have to know that you're generating load correctly. Because with server testing, you can have bottlenecks on the client that affect the apparent server latency when they aren't that at all. So I ran multiple tests. Okay, I had the luxury, I used CC2 8XLs, the largest systems we had, to generate lots of load. I was testing with 1 billion rows, a terabyte of data, up to 100,000 requests per second. And the way I was able to get to the point where I did that quickly was running lots of tests in parallel. The interesting thing is I found lots of things out. The server was great. I actually found lots of bottlenecks and problems in our client APIs, which we fixed before release. And just to give you a sample of what that looks like, I talked about Heisenberg. The default logging level for the Java SDK was debug. If you remember what I said, it was using very large instances, spinning up lots of threads. If you have, say, 150 threads, each trying to write to one log at the same time, the log becomes a bottleneck way before the server does. And so the first time I started doing these scaling tests, the blue line represents horizontally is number of client threads, vertical is throughput. I was seeing a bottleneck at about 8,000 requests per second, which isn't bad, but it is nowhere near what the system was capable of. Simply turning off debug logging changed doubled the throughput to roughly 16,000. Further changes that I made for this same hardware got the throughput up to 22,500 per second, which at that point was a bottleneck more on the network side than anything to do with the client. During that whole time, server-side latency was single digit. So I could say, yes, you were right, it's good. Now, the third choice, and I'll spend the rest of my time talking about this third choice, using benchmark reports that someone else has prepared. I've got a few comics here to lighten it up, but this slide is supposed to represent schools competing against each other, and if you can see it, the middle school starts with an advantage, and you would certainly love to be the middle school if that's how you were being compared. But this is called the unlevel playing field. Not all benchmarks are great ways to compare things or great ways to answer questions. As someone who's reading a report that someone else built, you really need to know what kinds of questions to ask to see if this is even worth looking at and if it's relevant. So here's some examples of the kinds of questions you should ask. What's being measured? Why is it being measured? What's the motivation? How does this benchmark resemble things that I'm looking for? And so if, for instance, you're interested in gas mileage, it doesn't do you any good to look at a benchmark of speed because you're interested in gas mileage. You have to also say, do I trust the way these reports were written? Can I even repeat them myself? Do I trust the analysis? Another comic here, just to give you a quick understanding of what's going on here. There are a bunch of animals here. The examiner is saying, okay, for this selection criteria, I'm going to ask you all to climb the tree. There's a monkey on the left, and that monkey is looking very happy because this test is made for them. There is a goldfish kind of in the middle that is probably in goldfish saying, oh crap, this is not good for me. So I'm going to actually give you some tips that I call the 4 R's that help you in testing whether benchmark results are really good for you. First, is it relevant? Is this test based on something even resembling what you need to do? Second, is it recent? Out-of-date tests, either out-of-date software, out-of-date hardware, or out-of-date requirements really don't help you. Repeatable is really important. How many people remember in the 80s cold fusion? Yes, a few of you. Some physics professors claimed they'd been able to demonstrate cold fusion in the lab. Unfortunately, no one else in the world could reproduce their results. In fact, they couldn't even reproduce their results. And so it essentially turned out, no, they hadn't done it. And sometimes that's something you have to worry about with whether results are really meaningful. Most importantly, is it reliable? Do you trust the tools? Do you trust the publisher and the results? There are lots of open source benchmarks out there that I won't use. It's not because I don't like them, it's because the results aren't repeatable. Some of them that I can think of, you run the same test 10 times on the same hardware. Everything the same. You get 10 different answers. Sometimes by an order of 10 different. If you didn't know it, you might say, and you ran those tests and one system was 10 times better than the other, and they're actually the same, you might say, oh, this is 10 times better. If you don't trust the tools, you can't use it. So I'm going to finish with walking through an actual benchmark that was published, benchmark results, and tease it apart to say what was claimed versus what was actual. So remember this picture. Basically, there's 2 vendors being compared. What was being compared was CPU performance for instances. The orange vendor claimed to be 5 times better than the blue vendor. I'm going to tease apart both what they claimed and what was true. The first problem with this was fundamentally a design problem. If you're going to compare 2 things, the fairest comparison would be to get 2 things that are rather similar. There were 8 different instance types in X. There were 5 different instance types in Y. All of Y instance types had 4 processors. They were all identical. The only difference between Y instances was the amount of memory. The X had a variety of configurations, with the smallest one having 1 core, a slow core, to the biggest one having 8 cores. Their 5X claim was based on their fastest result for one of their 4-core systems against the 1-core system. If I were to do this comparison, without changing the data, I took apart the graph and I said, here are the 2 systems that they tested that were most similar. This looks very different than the previous slide, but I'll go into more detail. There were actually test configuration problems. They ran all of the Y tests using Ubuntu 10.4. A fairly modern release, works pretty well on multiprocessor machines, which is what they're doing here. They ran all of the X tests on CentOS 5.4. In fact, I reproduced their results and found a problem. They were running on a kernel that was from 2008. It was a Fedora 2008 kernel, and if you know anything about that kernel, it's actually almost single-threaded on a multi-core system. So going back to one of those slides, yes, I could create a test where I could win in my sleep without problems, but you actually want to have fair comparison. So what I did was I ran the exact same workload on the exact same hardware, only changing the OS. This is what it looked like. The bottom graph is roughly more than barely a quarter of the other ones. It's the same hardware, it's the same test, only the OS is different. Another problem, there were actually analysis problems. I was able to get a hold of the spreadsheet used for this benchmark, and they had two critical errors. One was a cut and paste error, where they applied the wrong formula to the X instances, amazing. And they also, the second problem was they inverted a weighting scheme, where higher is better or lower is better. They mysteriously had it backwards for the X instances and had it correct for the Y. And so this graph, which is the original, higher is better, so orange looks incredibly good. Here's corrected. I haven't changed any data, I just fixed the problems in the spreadsheet that produced the graph. Okay? But I'm not done. So if you were to take all these things together, take the two most similar instance types, put them on similar operating systems, run the same workload and not have mistakes in the spreadsheet, and you were looking at just the CPU score, so just speed, where higher is better, what you would see is blue was almost 2 times better than orange, or X was almost 2 times better than Y, as opposed to orange or Y being 5 times better than X. However, most of us have to deal with real realities, and speed alone, people rarely come to you and say, price is no object, give me the best. No, they want to say price performance. So if you take the same data and apply cost to it, where lower is better, then the final result, taking apart this benchmark report, is that the blue was actually 2.13 times better than the orange. This is why you need to be really careful when you take the benchmark that someone else did. Personally, I don't like to make important decisions on something that I don't deeply understand and have the ability to reproduce. Especially, how many people would make a job critical decision by flipping a coin? I want to see if I can sell you some real estate, that's all. There's actually some good blogs out there on this kind of subject. About apples-to-apples comparisons and a good checklist on what kinds of questions to ask before you even consume the information like this. I want to say that not all benchmarks are bad. I'm not saying never read a benchmark report, they're all terrible, only do what you can do yourself. I am saying be careful. There's some great examples from Netflix about the benchmarks they did with provisioned IOPS on the HI instance type and also on Cassandra. They're great because they're fundamentally sound in their approach. And I'm not saying that because they were favorable to AWS. I'm saying these are really good examples of very thoughtful and disciplined benchmarks themselves. So summarizing what I spoke at a very high rate of speed. I had a little too many chais today, which is great for me but bad for you. But thank you for staying awake. You did a great job. Just summarizing, doing benchmarking is a really important way of providing real answers to questions, but doing it right is hard. It takes discipline, it takes focus, it takes some know-how. AWS is actually a great place to do this for all the reasons I cited. The best benchmark is one that most closely resembles what you use. The best benchmark is your application. You can run standard benchmarks, but make sure if you're going to run them that you do them in a careful and controlled way, as we talked about. You really want to be a careful consumer of reports that people have published, because, of course, everything on the internet is true, right? Okay, so I appreciate your patience with me. At this point, I will let you all know that there is a break. We will return at 4:30 in the main session, and I will be available down in the solutions area around the AWS booth if you want to challenge me or question me or any of the above. Thank you.